In this lab, we're going to use the plug-in transformer and this little rectifier, the LM317, to design a 10-volt DC power supply for a 1 kilo ohm load resistor. This is the LM317 voltage regulator. It has 3 pins: the input voltage, the output voltage, and the adjustment. The output voltage is determined by this equation, 1.25 times the quantity 1 plus R2 over R1, where R2 and R1 are resistors external to the circuit. In this lab, we'll use our voltage regulator 4-diode rectifier to create from our plug-in transformer to create a rectified output. We'll load that with 1/10 of a microfarad capacitor, and that'll serve as our input for the LM317. Here at our output, we should have 10 volts, and our load here is going to be a microfarad and a 1 kilo ohm load. Shown here is the circuit. This is the 4-diode rectifier here with a 0.1 microfarad capacitor across it. Over here is our LM317 voltage regulator. This is our 240 ohm resistor between the adjust and the input voltage. The adjust and the output voltage. This goes to our oscilloscope where we'll look at our output voltage. This is our DC output voltage. And you can see here we've got a DC output voltage. Well, here's a ground. So it's about 10.2 volts, just like we expected. However, we have a huge, almost 100% ripple here. We can reduce that ripple by changing the load from 1K to 2K, and by raising the load capacitor. And see, the higher the load capacitance, the less the ripple. So now here our ripple goes from 6.16 volts. Here we got a 6 volt ripple going from 10 to 6 volts back to 10. So the more you raise the RC time constant on that load, the less decay time you're given, and so the more it approaches 10 volts DC. That's our DC 10 volt DC regulator